about a mathematical relation that maps a set of input values to a set of output values such that each input value is mapped to exactly one output value. And what is that called? What is that? That's called a function. So that is what a function is. What I want to discourage you from doing is saying something like a function is anything that passes the vertical line test. Now, they may have told you that in Algebra 1, and that is perfectly okay in Algebra 1, but that is only true in the Cartesian coordinate plane. As soon as we get to polar coordinates, which are a big chunk of this course, then you can't use the vertical line test anymore, okay? So I need you to understand that is no longer a definition. You can use it in the XY coordinate plane, that's fine, but it's not a definition. A function is defined exactly the way it's defined here in your notes, okay? A set of input values is called these are the inputs. These are called the domain. These would be the outputs. So if you put in a 5, you would get out an 8. The 5 is part of the domain, and the 8 is part of the range. And again, because we are not always going to be working in X's and Y's, let's not think of domain as X's, let's think of domain as inputs. In the XY coordinate plane, X is domain, for sure. Okay. Do you know another name for the input variable? It's called the independent variable. The independent variable. The output is called the dependent variable. Can anybody explain that to me? Why do you think that is? Why do you think that is, Morgan?
The dependent variable all depends on what the input variable.
Yeah, when you, way back when you were little, and you had to graph something like this, you set up a T-chart, right? And what did you do? You put in some X's, right? And then you use those X's to determine your Y's. So these were independent, these were just made up, but these depended totally on these. So your range variable is also called your dependent variable. Okay, A, take a minute and see if you can figure out example 1A on your own. It says sketch a graph for this domain, -4 to 4, for the function below. We're doing A. The function f halves the input value and then adds 1. Could you write a rule for f? This is called a function rule, like this is an example of a function rule. Could you write the rule for the function that halves the input and adds 1? What would that be?
1/2 x plus 1.
Bingo. And if you are to graph that over the domain from -4 to 4, okay, let's put in -4. What happens if we put in -4? We get -1. So let's plot that point. We're supposed to be sketching this. All right, what happens if we put in 4? Okay, let's plot that one. And then, can I just connect those like that? Oh yeah, I can. Because what kind of an equation is this right here? mx plus b, which means it is it's a line, right? So aren't they gonna be linear? I mean, isn't it gonna be just connected? Yep. Now, could you also, if you wanted to plot more points, could you also put in, like I put in -4 and 4, could you put in 0 and 2 and -2 and all this? Absolutely. But as soon as you wrote this down, you should have recognized, oops, I have a line. And it's about B? What do you think's happening in B? Well, it looks like some of them I am, but not all of them. Okay, remember what your job is, guys. Don't overthink it. You're sketching this. So what do you think you should be doing? Just plotting some points. You don't have to write a rule. You didn't have to write a rule in this one either, but it helped. You don't have to write a rule here. You're just plotting some random points that are not going to be a line. I don't know, they're going to be some kind of thing.
It looks like a dinosaur.
Dinosaur? Okay.
Stegosaurus? What's the armored one?
All right, we'll use your imagination. All right, so we're gonna have, we're gonna do this basic vocabulary at the bottom, and then I'm gonna let you go to lunch, okay? Here we go, basic vocabulary at the bottom. An increasing function. If you are gonna describe this to your little brother, let's say your little brother just loves math, and you talk about math with your little brother, and you're talking about an increasing function, what would you say? The slope is positive, right? In other words, as we go from left to right, it goes up. Now the formal definition is there. It says if the input values increase, then the output values increase. That makes sense, right? Okay. A decreasing function is just the opposite, right? As we go from left to right, the curve is gonna go down. So as the input values increase, the output values decrease. Concave up. This may be a term you've never heard before. Have you ever talked about concavity in your other math classes? Well, concave up means that the rate of change of whatever function you've got is increasing. What does concave up look like? A bowl. Yep, a bowl, a parabola, a cup, whatever. But here is, underline it, circle it or something. Concave up means the rate of change is increasing, which means basically the slope is increasing. If you are concave down, then your shape is I don't know, what do you think of that? I don't know, an upside down bowl.
A mountain.
A mountain. If you're concave down, then your rate of change is decreasing. Highlight that, underline it. That is going to be a critical piece of stuff that you remember. So concave down means your slope is decreasing. Concave up means your slope is increasing. All right. Okay, there we go. Hang on to all that stuff.
Sorry,
We're
it's
gonna
a
come
really
back to
big
it
book.
another
Is that
time.
better?
Yes, that's better.
But like the new big ones, they don't go up at a point.
Yes, they do.
No, they usually just
Yeah.
round off.
You're gonna have to roll
Yes.
fast.
Yeah, but-
Done.
That's